This week we're going to look at aggregate functions, and I'm going to go ahead and create a new query file, and let's save this as documents week for aggregation. And the book refers to this as summary queries. So let's go ahead and start with the IMDb database again. Use IMDb. And this week we're going to use title basics and episodes, title episodes, and title ratings. So let's start by writing a join that joins those three tables together. But before we do that, even what I'm going to do is I'm going to select top 50 star from title basics again. You've seen that table before. And select top 50 star from title episodes. So that's a new table for us. And select top 50 star from title ratings. So let's go ahead and execute all those statements. So title basics is the same as before. There's a tconst, which is the ID for a show. You'll notice that there's a title type, which is short. Can also be TV episode, TV series. That's what we're going to use this time. And some other data which we don't really care about. Just title, title type, and tconst. And then in title episode, what we have is the tconst, which is the ID for an episode of a show. There's parent tconst, which is the ID for the series that the episode belongs to. And then for an episode, you have what season the episode appears in, and also what episode number the episode is in that season. And then in title ratings, we have a tconst, which is either an episode or a series or a movie or whatever. There's basically any show can have a rating. There's the average rating across all IMDb users who voted for that particular show. And then there's the number of ratings that were gathered for the show. So let's start by joining these together. So let's select top 50 star from title basics, and then we're going to join that on title episode on, and then I'm going to alias these because I'm going to be using them in the queries a lot and get tired of typing all of that stuff. So as, that'll be TB1, because I'm going to have a TB2 in a minute. And then title episode as TE on te.tconst equals tb1.tconst. So this is going to be the name of the episode in title basics 1. And then I also want to join with title basics as tb2 on te.parent.tconst equals tb2.tconst. So this is the information about the episode. This is the information about the series. And because I'm using inner joins here, this is going to drop out any result that does not have an episode series relationship. So for example, if I have a movie, movies are not going to show up in title episode because there's no parent series that the movie belongs to. And so this query is only going to return TV episodes that belong to a series. And TB1 will be the information about the episode. TB2 will be the information about the series it belongs to. So let's execute this much so far. And what I have in title type should be a bunch of episodes. So here's an episode. Here's the name of the episode, the year the episode was produced, the runtime, and then here's the title episode data. So the episode, the series it belongs to, season number, episode number. And then here's the information about the series it belongs to. So you see the title type here is TV series. And then I have the primary title, original title, and so on, the usual title basics. So for example, I can see that The Tenderfeet is season 1, episode 9 of The Lone Ranger. Now let's go ahead and join title ratings. Call that TR on. And then I want the rating for the episode. So that's going to be title episode.tconst equals title rating.tconst. So let's look at that. So now I have the same information as before, and I also have the average rating for that episode and the number of votes. And for this dump of the Internet Movie Database, it's going to exclude shows, episodes that have below a certain number of ratings. So less popular series, you may only get a couple of people who vote ratings for a particular episode, and so that data might not appear here. And since we're using inner joins, we're going to drop those episodes out as well. But I actually want to include those even if there are not enough ratings. So I'm actually going to use a left join here and fix my tabbing. And then I'm just going to have nulls here for the tconst average rating and num votes if not enough IMDb users voted for a particular episode. So let's see if I can find one of those. Yeah, so here, actually, let's go ahead and yeah, so there's actually quite a few episodes that don't have enough votes for them to show up in this list here. So let's go ahead and pick out some of these columns that we're interested in. So I'm going to include title basics 1 dot primary title, and that's going to be episode name. And then let's do title basics 2 dot primary title as series name. And then I want the season and episode number. So let's go ahead and do title episode dot season number as season, and title episode dot episode number as episode. And then let's include title rating dot average rating as average rating, and then title rating dot num votes as number of votes. So let's go ahead and run that query. Good. So this is the information I have coming back. And then I'm going to focus for the aggregation for this part, I'm going to focus on a particular series that has a lot of episodes. So one of the longest running shows on TV is The Simpsons. So let's go ahead and find the episodes for the series where the series name is The Simpsons. So where title basics 2, that's the series name, is equal to The Simpsons. And then it should be tb2.primary title. And then this is going to be, I think it's like over 25 years worth of Simpsons, and, maybe 20 some odd episodes per year. So this is going to be a fair amount of data, but it's not going to be so much that I really need to prune it. So here's all of the episodes from The Simpsons. And what do I have? I end up with 638 episodes of The Simpsons. Wow, that is quite a lot. And I think probably the most sensible way of ordering this is by season first and then by episode. So let's go ahead and order by season, comma, episode. Okay, so there's our base query. And for some reason we have 4 episodes where there's no season or episode specified. I'm not exactly sure why that is, but the rest of them all have season and episode information. And actually we 30 seasons in IMDb. The last season hadn't aired when I grabbed this copy of the IMDb. We'd only really aired up to season 29, episode 21. But those were new and hadn't been rated yet. Okay, so that looks like everything we need to start. So I'm going to go ahead and put a go in here, and I'm going to copy this query and then use that to start editing. So what might I want to know about all of these episodes taken together in aggregate? So the idea of aggregation is I'm going to take a set of data, for example, like all of the rows in this query, so all the episodes of The Simpsons, and I want to summarize that data. I want to squish all of these rows down into one summary row that has some key information about the results that I'm summarizing. So for example, if I squish all of these down, well, this episode name, there's no way to squish that down into one value, right? I mean, I want one summary row. There's no way of summarizing the episode name because that's going to be the same. Series name is going to be The Simpsons. When I squish that down, season and episode, I might want to know the total number of episodes. That would be a good thing to know. Average rating, I might want to know the average of the average. I might want to know the average number of votes per episode. I might want to know the lowest rating for any of these episodes, the highest rating for any of these episodes, the lowest number of ratings for a show, the highest number of ratings for a show in the series, and so on. And so the aggregate functions are going to let me do that. So what I'm going to do is I'm going to get rid of all of this stuff. And, oops, let's fix that. So select. So the first thing I want to know is, let's just start with the rating. So I want to know the average of the average rating column. And that's in title ratings dot average rating as average rating. And then bear with me on this order by. We're going to talk about that more later, but for reasons that I'll get into, I can't include that. So if I execute this query right now, I get one row of results coming back. So it took all of the rows that I had before for all of the episodes of The Simpsons, and it squished it down into one row with summary information in it. So the average rating across all the episodes was 7.32. I might want to know the lowest rated episode. And I might want to know the highest rated episode. That's max. And then I might want to know the total count, the total number of episodes that I'm aggregating. and we'll see some more examples of count. But basically I'm saying this star here means just take each row as distinct and just count the total number of rows. So let's go ahead and execute that. And what do I see? Let me get the whole thing. So I see the average rating across all episodes was 7.3. The lowest rating was 4.3. The highest rating was 9.3, and there were 638 episodes. Now, the way that I'm averaging these ratings together is not quite right, because some of the episodes had a higher number of votes and some of them had lower number of votes. And so if I wanted to average the ratings across all of the votes as opposed to across all of the episodes, I have to do some more work here. So this is one valid way of looking at it. This is the average rating across episodes, but I might also want to know the average rating across all the votes. So let's do that. I'm going to copy this query. And in order to come up with the average across all votes, I have to sort of reverse engineer things a little bit. So let's look at this original query here where I'm showing the disaggregated data. And I see, for example, if there's an average rating of 8.2 with 4,297 votes, and then an average rating of 7.8 with 2,438 votes, what I can do is I multiply this times that, and multiply this times that, and then I add those two things together. So that gives me the total number of points for all the votes, and then I divide by this plus that. So let's look at that math. I'm going to go ahead and pop up a calculator. So BC. So if I have an average rating of 8.2 across 4,297 votes, that's 35235.4 total. And then 7.8 times 2438 is 19016.4. So I do 35235.4 plus 19016.4, and then I divide that by 4297 plus 2438. That's the total number of votes, and I get average score of 8. And there's some rounding here, so let me fix that. I'm going to BC-L, and then I'm going to execute this line again. There. So here's the unrounded version. So I get 8.05, which is pretty much right in the middle of these two, but a little bit higher than right in the middle. So average, if I just average the two ratings, 8.2 and 7.8, I'd end up with 8. But there were somewhat more votes for 8.2 than there were votes for 7.8. So that causes the average to be a little bit above 8, and that's what I'm calculating here. So the difference between average of the average rating versus the math that I just did here, which is the sum of this divided by the sum of that, is this is unweighting based on each individual vote. So how do I actually calculate that here? Well, let's go ahead and I'm going to get rid of, I'll leave this one here, and I'm going to start with some math. So I have, let's go ahead and do sum of tr.numVotes as total votes, and do sum of tr.average rating times tr.numVotes as I'm call that total points. So let's execute that. So total votes, so on a scale from 1 to 10, like if you voted for one person votes a 5, that's 5 points. Another person votes an 8, that's 8 points. So 5 plus 8 is 13 over 2 votes. So that's what total votes is. I'm sorry, that's what total points is. So total points is going to be the sum of those ratings, and total votes is how many people voted. So if I divide this by that, I should get an unweighted average rating. So that's going to be this number divided by that number. That's not the right one. This one. That one. And I'm going to call that unweighted average. So let's go ahead and execute that. So the average rating was 7.3, but the unweighted average is actually a little higher at 7.6. And there's actually a reason for that if you think about it. When the show was actually hitting on all of its cylinders and was good a long time ago, it was good, more people were watching and more people voted on those episodes. Now, the show is not as good, and fewer people are watching it, and fewer people are voting on it. And so if you're just looking at total number of votes on an episode-by-episode basis, there are more votes when the series had higher ratings and fewer votes when the series has lower ratings. So the unweighted average in terms of votes is going to be higher than the average rating across episodes.